And number 9, we're asked to figure out where a plane intersects the x-axis. So let's think about our picture for a second, if you will. So we've got our 3 dimensions. We're going to intersect the x-axis. If we think about a plane, it goes through. There's my plane. Okay, where am I intersecting the x-axis? Well, right about there, right? What do I know about that plane? Well, on that plane, right there specifically, I've got an x value, but I have no y value, and I have no z value when I'm directly on the x-axis. And that's true for all those points. So using that idea, I can actually use my parameters to solve for s and t, and then I can plug it back into x. So what do I know? I know using the y one, y has to be 0 on the x-axis. So I got 5 plus s plus t. I know the same thing has to be true for the z one. So 4 plus 2s minus t. I'm just going to rewrite this one underneath it so I can use my elimination. So 5 plus s plus t. My t's are opposite signs. We're going to add. I've got 0 equals 9 plus 3s. Or in other words, s is negative 3. Okay, if I go back to one of my original equations, that one up there, let's say, I'm just going to change the format. So negative 5 equals s plus t. But what did we just figure out? S was negative 3, right? So negative 5 plus 3 is t. So t is negative 2. So I did that so I could solve for s and t, so I can figure out x. X is equal to 3 plus 4s minus 2t. But we know what s is now. S is negative 3. And t, we just figured is negative 2. So we end up with 3 minus 12 plus 4, which is negative 5. So our plane is going to intersect the x-axis at the point negative 5, and y was 0 and z was 0.